very welcome everyone who's listening. Normally you're going to learn today about the basics of the CSC API version 1.0. So first of all, here you can see the agenda of the talk of today. So first I will give an introduction of what is the CSC API, what would we have available for this API. Then I will go into the detailed description of the functionalities of the API. And then in the last part, I will give over to Andrea Valle, who will present the conformity checker and will show in a small demo how the protocol works in real life. So let's start. What is available for the specification? So we have now a version 1.0 that is published on the homepage of the Cloud Signature Consortium on the link there. So normally you have to give in your name to get them, but still they are available. There is the technical specification, but there is also JSON schema for the different types and an open API specification for the whole API. And now, not now on the homepage, but on the doc box, there is a conformity checker, Andrea will present later on, that allows to check an API if it conforms to the specification or not. That's kind of the available documentation we have. Then I just want to shortly explain the situation, the architecture where we find the CSC protocol. So we have a signature application that is normally has the document, shows it to the user, and then the user says, okay, I want to sign. The problem is the application probably does not itself manage the keys. So what can it do? The idea is that we have a provider, a remote signing server provider or signature service provider, the RSSP, who has the key in a remote signature creation device, RSCD. And the user has the possibility to connect, to allow the usage of this key that he has in the remote service. So the idea is then that the signature application, the user will say to the signature application, okay, here's my document, I want to sign it. The signature application asks the user, okay, do you have a key somewhere? And he said, yeah, I have it by that provider. Then the user the signature application will contact that provider, and the user will authorize the signature. And in the end, the remote service will just do the cryptographic signature, meaning, so for the moment, meaning it takes the hash value of the document to be signed and signs it cryptographically with the key. It does not do anything about structure or anything else. Sends this signed value back to the signature application, and the signature application gives then the big document back to the signer. So that's the main part. Then we can have also some other actors in the architecture, like the CA issuing the certificate used in the signature, or there might be even another corner, the ID provider that handles the authorization of the key. So there are different elements, but for the moment, the protocol itself just handles the connection between the signature application and the remote signing server provider. So now we'll go directly on the API description. So the API has several methods, and you're going to learn what they can do and how they're used. So first of all, to use the service, you need a service authorization, meaning you have to prove that you have the right to use the API of the service. There are two possible ways: OAuth, which is for the recommended version, and basic HTTP, that is less secure, but for example can be used for tests or when there's not that much security needed. How does this work, the service authorization? We have methods that help to obtain an access token with a specific lifetime. And then the access token will be sent each time the API is accessed and is kind of used to prove the right to access the service of the API. And there is the possibility to revoke such an access token, for example, at the end of the signature workflow. And it might also be the possibility to refresh the token. That depends on what the remote service supports or not. So I will shortly explain the two cases. So the simple version, how does the HTTP, basic HTTP work? So there are two methods within the API, auth-login and auth-revoke. And you can see on the right-hand side the workflow. So the user gives the username and the password to the signature application. The signature application will send this information within the request to auth-login in a basic HTTP format. The remote service will create an access token. And then the user will use this access token each time he accesses to the service. And in the end, he says, okay, I've finished. He closes the session and the signature application sends a revoke access token to the service, and then the access token cannot be used anymore. In case the access token is almost expired, it's the possibility to, if supported by the service, to refresh the access token, and this is also done again by the auth-login method. Then for the OAuth, the thing that has to be taken into account, normally for most of the API methods, we have a base UI. It's the same for all the UIs, for all endpoints. The only exceptions are methods for OAuth. There can be one separate, different base UI. For the moment, we don't support to have different base UIs for different OAuth methods. There's one base UI for OAuth method that can be different of the basic service. There is for the service authorization with OAuth, scope is service. And there are two possibilities to use OAuth. It's the authorization workflow, as described in this example, or the client credential flow. As for many things, it's always the provider that can decide what he supports or not and gives that information to the user or to the signature application. What are the methods, the API methods for the OAuth authorization? We have OAuth authorized, that's needed for to get the authorization code. We have the OAuth token that's used with the code received before or with the client credential. And there is OAuth revoke, to revoke the access token. due to backward compatibility, there is the possibility also revoke the OAuth token, or a service might propose the possibility to revoke an OAuth token using the the basic OAuth revoke API. But it's not at all necessary, but it's a possibility instead of the OAuth revoke method. So I will shortly go again on the workflow. So how does it work? The signature application will request an authorization code to the authorization server. And the user say, okay, the user will directly talk to the authorization server. So he sends his user name and password not to the signature application, but directly to the authorization server. The authorization server then gives the code to the signature application. And with this application, the signature, with this access code, the signature application requests using the OAuth token method, the access token, which then can be used again to access the service of the remote service, the API of the remote service. And you can see it's not necessary that the authorization server and the remote service are the same entity. They can be different entities. And in the end, we have again the closed session, which revokes the access token, this time for the using the endpoint of the authorization server. There's one more possibility I want to mention for OAuth for the service authorization. There's the possibility to have a restricted authorization server. The idea is, normally for an authorization server, everyone is allowed to send a request there, and then just afterwards it will be checked during the process if the one who requested it has the right to do so. But there might be situations where this is not wanted, or and then it's the possibility to restrict access to the authorization server. And this can be done by requesting an access token, or GWT access token, containing some information. What is also interesting, the information, and that this information states the user connecting to the authorization server is allowed to do so. What is interesting, the information in this access token is not necessarily the user itself. So there can be somebody else, a group of clients, or somebody that, for example, asks the signature of for somebody else, that gives the authorization to access the service, to access the authorization server, but it's not linked to the user itself that will connect. This is kind of interesting for this access token. Then the next interesting endpoint is the one to request the service information. This endpoint gives information on the service provider, like the name, the logo, just information on the provider itself. But it also gives information on the service authorization method, because that's needed to know how to access the service, and also which methods are supported. For example, you can support the timestamping or not, or sending of OTP or not. So it will explain which methods are supported by the specific service. So this method, the info method, so the API method providing this possibility is the info method. The info method does not need any authorization. And it's very important because it really allows that this protocol works for many people for many different situations, because every provider can state what they support, and the application using the provider doesn't have to know this beforehand. They just check the info method and then automatically knows what it can do or not. Then we come to the credentials. So what is a credential? A credential is, we say, a key and a certificate together, more or less. So if we want to know, so there's a method to get the list of credentials for a specific user. So this only gives the credential ID. It does not give more information on that. It's really just a list of numbers or names or IDs. And there are two cases where this can be used. The, I would say, classical case the classical usage is that the user has connected to the service and wants to know which are the credentials I can use, I have available. So this will give the list. The second possibility is to have, I have access to the service with an account that does not have itself credentials, but is allowed to have a to see which credential have different users of a community. Such a community can be, for example, the clients of a specific bank. So an administrator of the bank, with an employee of the bank, has the right to ask which, for a specific user, which credential it has, but it does not have the right to sign with this credential. It just has the right to ask what is there. And in that case, for this method, we have to provide the user ID as well. If the user asks for himself, it does not provide any user ID. This method allows to handle large lists. Not sure if this is really needed, but it was proposed at the beginning. And the corresponding method is the credential list method. Then the credential info method allows to give the information of a specific credential. This provides, so when applying this method, you can specify which information you want to know. For example, do you want to have the certificate or the certificate chain? Do you want to know how to authenticate, how to authorize, not authorize, how to authorize the usage of the credential, and also what is the maximum number of signatures during one authorization, because there might be providers that say, okay, for each signature you have to authorize this, and there might be providers that say, okay, or credentials for which I say, okay, you can authorize once and then you can do up to 10 signatures, for example. The corresponding method is the credential info method. So now we come to the credential authorization. How does this work? Before signing itself, we will create an authorization to sign. For this, we will create a signature activation data, which we call set. The authorization is for one or more hash value. depends. So for one or more signatures of hash values. In case, so there's a property for a credential that we call skull. It's related to so it's sole control assurance level, and it's related to the sender command. And if the value is 2, means we want to we need to provide the hashes we want to sign at the moment we authorize the signature. If it's the value is 1 for a specific credential, it's not needed. And there are 3 ways to authorize the usage of a credential. It's explicit, implicit, and OAuth. So we have again some flowcharts. First of all, the explicit one. This means the remote service relies on the signature application to collect some information in the environment of the signature application, and then sends this information to the service. This information collected can be either a PIN or an OTP. The API methods that are used for this are the credentials send OTP. I will go into details on that later. And then the credential authorized. So the example here, we show how to do a credential authorization using a PIN. So in this case, the user will send the document and the PIN to the signature signature application. The signature application will call the method credential authorize using the credential ID of the user, the PIN, and eventually the hash of the document, depending if we have SCAL 1 or SCAL 2. And then the remote service will create the corresponding sets. And then later on, when creating the signature, we will use the signature sign hash using the set and the hash to be signed, which will then receive the cryptographical signature of this hash. And then the signature application will send the signed document to the user. The second possibility is the implicit one. So implicit authorization means that the remote service itself takes care of contacting the user and asking him if he's okay to sign or not. This can be done during a push notification. For example, also a technique you want to see, you can imagine, but it's the remote service itself who does it. So the API method used here is just the credential authorize. And if you look at the example, we have the user says he wants to sign the document. The signature application calls the credential authorized just with the credential ID. Then the remote service will itself contact the user, for example, with push notification on the phone, ask, do you want to agree to sign? The user say, yes, okay, I'm fine with that. And then afterwards, the remote service will create a corresponding set that again will be in the end used to create the signature. And the last variant is the OAuth. So here we have the scope credential. This time only the authorization code flow is allowed. And in case we have the SCAL 2, the hashes are provided in the OAuth authorize method. So two methods are needed, the OAuth authorize method, which retrieves the access code, and then the OAuth token again. So in the workflow, we see the user says to the signature application again, I want to sign. The signature application sends the credential, sends the information to the OAuth link with scope credential. The authorization to send it to the authorization server. The authorization server will talk to the user for the authorization, returns then the code. Then we use the OAuth token to create the set based on the code. And then the set is used again in the signature sign hash method to sign really the hash. So that was for the authorization of the credential. I want to explain a bit how it works with the OTP. So there's a special method send OTP that requests the sending of a OTP for a specific credential. The request is not related to a signature request. So it's just very stupid, send an OTP to this user for that credential. That's all the information we have. The API method, which corresponds to that, is credential send OTP. And the workflow, the corresponding workflow is such that the user sends again the document to the signature application, which sends the request OTP to the remote service. The remote service will send the OTP to the user. The user will type the OTP to the signature application. The signature application will then send the OTP and the credential ID to the remote service, which will create the corresponding set, and then the set will be used again for the signature in the end. So we are almost in the end of the API. So there's a sign hash. How does this work? We've already seen it actually a lot. So it will create the cryptographic signature value based on the set and the hash to be signed. It's possible to send multiple, so if it's allowed to have the multiple signatures for one authorization, we can do this either by sending all the hash, the whole number of hashes we want to sign with one authorization at once to the sign hash, or we can send it in several times with the same set. And the corresponding API method is signature sign hash. So that was already everything, yes, from the API. So are there any questions? Since we are quite fast, are there any questions on this part, on the API part for the moment?
Yes. This is Georgia from the Secretariat. We have seen a couple of questions coming in.
Okay.
The first one is it necessary to have revoke access API even if the service provider is automatically revoking the access?
No, so it's impossibility to do so. So it's it's good to implement it, because the question is, when do you revoke it? If a user wants to revoke the access, so before the whole process is done, it's good to have it, but it's not mandatory that the signature application sends a revoke in the end. It's a good thing to do so. And I think especially the revoke, it's really good to provide it in case something gets wrong. Because if you say you revoke it automatically when after a specific time, when it's not, so it's a good thing to revoke, but it does not mean that, I mean, it has a limited lifetime. So already after the lifetime, it cannot be used anymore. And yeah, I think it's a good way of doing things. But most of the, yeah, go ahead.
Yeah, sorry, Andrea. This is Andrea Valle speaking. I would like to mention something. Andrea is absolutely right, but I think that let's say it's important to say that the client has the freedom to decide whether it wants to revoke an access token or not. But it's important that a service would try to always implement a revocation service, because, for example, in the Adobe case, I mean, Adobe as a client to your remote services, we essentially expect the ability to revoke an access token. And therefore, it would be very problematic, let me say, impossible to work with a provider that does not implement the revocation method. So it would be important. And let me just add something that some of you already know, those who have already implemented the service that are already connected to the Adobe ecosystem, is that we, as Adobe, provide an Adobe profile for the CSC that describes what Adobe expects a provider to implement in order to be properly connected to Adobe. So this is, of course, not officially part of any CSC, I mean, any consortium official document, because this is our own profile of the CSC, what we expect a provider to implement. But that's also important, because if a service provider wants to connect to Adobe, it's important to know what Adobe pretends a provider to provide. So this is an information that we can provide to those providers who want to implement a service and they want to connect to Adobe. And in this case, the auth revoke method is a mandatory one.
So it's there as Andrea explained correctly, there's the protocol itself, and then there is usage of the protocol. And so Adobe uses the protocol and has its own rules. In the same way that a provider uses the protocol, it does not have to implement everything, but if they want to work with Adobe, he has to provide everything that's needed for Adobe. So we wanted to have the protocol itself as flexible as possible, but then there are specific situations where you have to yeah, decide on what you need or not, which with authorization methods you accept, for example, or not. So it's a lot of small profiles you can have on the whole protocol.
Yeah, sure.
I saw there is another question. Is send OTP a credential authorization method itself? No. Send OTP only sends an OTP. This OTP cannot be used in the sign hash method. For the sign hash method, we need a set. And to get the set, you have to use either the OAuth token method or the credential authorization method. Then the credential authorization method can use the OTP received, but the OTP itself cannot be used as to authorize a signature. Any other questions? I don't see the general ones. The chat, I have problems, so just tell me.
No, the chat is locked on Benita Lips for me. So.
Ah, okay.
Just a question in the send OTP method. Could we imagine to add a send FIDO method to use the FIDO protocol for the second factor, for example?
Why not?
Yeah, let me talk. Well, first of all, who was asking the question? Sorry, just if you introduce yourself, so we don't.
Okay, excuse me. I'm Olivier Sono. I'm director of new service in DocaPost France.
Okay.
The subsidiary of La Poste in France.
Perfect, perfect. Good afternoon. So the answer is pretty straightforward. So we had already discussion about this when developing version 1, and actually we already have a proposal that we have started working on to extend the existing authorization mechanism to additional mechanisms. For example, to use SAML or OpenID Connect and why not FIDO. So this is part of the version 2 that we want to work on in the technical working group in 2019. So yeah, definitely this is an area that has been already confirmed by multiple members to be an area of interest. So my invitation is, if you are particularly interested in this, please raise your hand and be part of the team that we will work on this. So this is, let's say, definitely something we wanted to extend in V2, and this would be this year technical work.
Okay, so I accept the invitation.
Okay.
I'm interested in working this way.
Okay, perfect. So let me just say that for the moment, we have the OAuth mechanism essentially can and has already been used as, let me say, a container to leverage non-native methods for authorization, and of course also for service authorization, which essentially we can say user authentication. So this means essentially that as OAuth is using HTML as a container, you can already use let's say a FIDO token, for example, embedded into the OAuth experience. Of course, not, I mean, completely straightforward from an implementation, because you needed to, let's say, develop an authorization server and let's say user interface for that. But this is immediately available. So I know that at DocaPost, certainly Miss, you are interested in that. We discussed this already with Frank Leroy in the past, and currently the option is to embed the FIDO management through HTML pages, which means, for example, JavaScript or whatever else you have for FIDO library, and use OAuth for that. But for the future, as well as SAML, for example, or OpenID Connect, the idea is to support them natively, so we don't have the overhead to use an OAuth container, which in some cases may be overkill, or just, let's say, reducing the security of the implementation itself.
Okay, I note that it's available with OAuth on HTTP, yeah. And Frank is not part of DocaPost right now.
No, I know. I just wanted to mention the fact that we used to discuss this already, so we know this is interesting in particular for you. But again, let's say we'll go soon talking with the entire technical working group to start working at the topics that many of you have, let's say, voted to be an interesting part. So you will be soon involved in those activities, and therefore we are not too far from starting working on this.
I'll be there.
Okay, thank you very much.
Okay. So I think Benita told me that we've covered all the questions for the moment. So I will give the hand to Andrea to present the conformity checker.
Automated checker. Yes. So the conformity checker is essentially a tool that allows to automate the testing of a remote service for conformity to CSC API specification and to performance analysis. So this tool is a tool. I will let you know later how you can access it, but it's a tool that has been developed internally, and that's from today it's available to every one of you, to all CSC active CSC members. And this is a very, very interesting tool to support the development of remote services. So currently, it's based on the V0 implementation. So I know that today we are talking about V1. We recently released the specification, but you have also, it's important also to know that all the existing implementation currently still support V0. And let me also spend a word on this. So all the active members are suggested to move to V1, but at the moment, all the existing implementation, including the client side from Adobe, are based on V0. So this means that anyone working on an implementation right now has also to support a V0 endpoint, but those who are starting now developing a solution have to definitely start implementing a V1, because in the course of 2019, everyone will also migrate and support V1 as well. So for the moment, the tool has not been recently updated after V1 has been released. So it's still based on the public pre-release that we released last year, 0179. So this tool is essentially based on test profiles to define a test target. So for example, I mentioned before the fact that Adobe Sign has its own CSC profile. And for example, you have the ability with a conformity checker to apply a test profile for Adobe Sign. So this means that if you want to ensure that your service will meet the Adobe requirement, then you simply select the Adobe Sign test profile, and the conformity checker will make sure that everything that's required by Adobe will be tested and evaluated. Of course, these test profiles are not bound to Adobe, to the Adobe profile, and they can be customized to suit specific functional targets. So if you have a different client, you also are developing a different client with a different set of functionality, you can write your own test profile so that the conformity checker will perform a set of test and control based on your requirements. So the conformity checker, well, we call it shortly also COACH, so conformity automated checker, which is easier than just tell the entire word, is a Java-based tool And also for the CSC members, we also have the full source code available. So I will talk about that later. There are user guides available in the repository itself. And there's also complete Java doc implementation that you can also look for APIs if you are, if it's easier for you to integrate in other test tool or automation tool like JUnit or whatever else you're using. The test service configuration, which means all the configuration for, I don't know, the username and password for users, or the OAuth client ID, client secret parameters are defined as text files, so they can easily be configured up front. And the output files, which are essentially two different types of output file, test result and response time result, are available in JSON format, so they can also be used for different purposes than just human reading. Of course, there are logging capabilities, so you can also view more detailed information and connect this information to other tools. Next slide. Okay, availability. So this tool has been developed by Intarsis. Intarsis, I don't think Thomas is here today, unless I missed him from the list of participants, but Intarsis is one of the first hour members of the CSC. Thomas is also the vice chair of the technical committee and very active contributor to the specification. So this tool has been developed by Intarsis for Adobe, and Adobe has decided to donate the project to the CSC for exclusive use by active CSC members. So from today, as I said, the tool is available for all active CSC members. The source code is also included. For the moment, the type of license is still TBD. So we wanted to make it an open tool, but only for active CSC members. For those who don't have, let's say, their own service to test, I think we can have some of the existing providers to provide also test the credentials for their service. So if you want to see in details how this service work, we can work either with Intesi or Seco or InfoCert to provide test access to their services. So next step with Coach will be that we'll see if there is interest to organize a dedicated webinar to learn how to use Coach. Maybe Thomas or someone from the Intarsis original developers may also help to speed up the learning curve with the tool. From the CSC, we also want to maintain the development internally. So we will evaluate the resource and budget needed to maintain the tool. As I said, currently is still based on V0, so we need to update it to support V1 and also future CSC specifications accordingly. Another area could be to develop more test profiles. For example, someone may be interested to develop, for example, an EU qualified test profile to make sure, for example, that a remote service supports the production of qualified signature according to EU standards and regulation. And of course, being an open tool within the CSC community of members, we want to make a call for Java developers that are interested in becoming active contributors. And the idea is that we could create an internal repository for the source code and see if we have the resource to make this project a shared project among the members. If not, we'll have to work on allocating some budget to have either Intarsis or someone else to just work on a project basis with a paid approach. Of course, we need the budget for that, so it's not yet decided to have this approach. So let's see if we can work at it with as an open development project, and then if this will not be successful, we'll see what to do.
Just a small comment on that. I think we will see now that it's available for all the participants, that how people can use it. And then I think once we get the feedback really for people using it, then we can also see how much people are motivated to work on it and how to go on. I think it will be interesting to get that feedback.
Yeah. So exactly for this reason, I want to just say something important, that the idea of the conformity checker is also that Adobe is intended to make the coach report be part of the pre-requirement from Adobe to onboard or maintain CSC providers. So we spend a lot of resources in testing new services or in running performance tests. So this has been so far acceptable because we have been in a very initial ramp up approach. But moving forward with the growing number of providers, having a coach report as, let's say, an input to us would let us and also those who implement the remote services help save a lot of time and have an objective, let's say, way to evaluate also the capacity or the performance or a very detailed report on the supported capabilities. So this is also important because it's not just, let's say, an option, but this may become, let's say, an important tool to work with Adobe. Is there any question about this before we move to the next section? Okay, doesn't look so. Of course, feel free to reach out to either Andrea or myself, and as soon as you have tested it or you had a look, maybe you have more feedback, so you will let us know. Okay, so I think we can move to the next session.
Exactly, so to the demo. So I will stop sharing, and Andrea will show how the usage of the protocol can work in real life.
Okay, well, this is just to complete the previous section on the conformity checker. Here you can see the Dropbox with 2 files. So this we have a bunch of people that are authorized already. If you're not, just let us know. So for the demo, essentially, well, as you know, if you have already evaluated the document, the CSC API V1 already contains some examples that we have created using Carl. I think everyone is familiar with this tool, but essentially is an HTTP client that can work from a command line on multiple platforms, or also as a library if you want to integrate in other tools. Of course, there are even better tools than these, Swagger or Incognito or other tools that are essentially REST API client. I think if you are a developer, you may already be familiar, or you can see in the market there are a lot of options. But I want to show the use of the API with Carl because they match the official document, and they may also be easy to understand if we go step by step. So the idea is now to make a complete demo. I have summarized essentially all the main API calls that you find in the specs, and essentially following the same scheme that Andrea has explained before. And just to show you very quickly how this behaves in practice. So let's start with the info method. Well, okay, just an information up front. So which service I'm using right now? So I'm using a service that we call the CSC test service that Adobe has implemented for itself in order to essentially have a test service to evaluate our own client, CSC client capabilities without necessarily relying on a real external third-party provider. So this test service can also be available to you if you want. If you are interested, just let me know, and I can provide access as a user to this service. This may also be useful for you if you want to see how a working service works, and that could also be helpful for you as a developer. So in this case, let's start from the info method. So I'm copying here the command. I'm on a Windows machine, so you will see these strange three quotes here. Is the way to work around some limitation that there are on the Windows platform for quotes. So just to explain the general syntax, the -I means to have some more information about the HTTP. Minus uppercase X post is to just force a post verb for the HTTP, while the default is a get. The -H is a header, in which essentially we force the application/JSON, which is essentially the standard for the CSC API. And the -D is essentially the body of the data that we send to the endpoint, and this is the endpoint. So the first part is the base URI for the CSC test service, and CSC/v something is our appendix specific for the CSC API, and in this case is still based on V0 because this service is still on V0 itself, and info is the method. So when we hit okay, sorry. Okay, does it work? Sorry, let me try again. I think I was playing too much with my cursor. Let me copy again. Okay, so you see the answer. Maybe let me reduce a little bit the screen. So you see, first of all, the answer, 200, okay, it's okay. And then we have some data header and here the response. So here you see that the methods, there are some methods supported, region, logo, the OAuth endpoint is here, right? This, as Andrea said, it can be different from the other one. In this case is the same, but not necessarily. And then we have a description name. And here also very important, the type of authorization mechanism that are supported. So for example, this service only supports basic authentication and OAuth with authorization code flow. And also important here, you see the specification that are supported. So in this case is a V0 endpoint, as you see in the request. The specs are the well-known V0 pre-release. When this endpoint will be updated to a V1 endpoint, then the specs will likely be 1.024 or whatever to, I think it's 3.0, the existing public API. So the first step is essentially call these from a client to see this key information. The next step is login. So let me show you first login with basic HTTP. So in this case, I'm using a user that has Adobe Demo as username and password as password. Very, very secure, of course, but it's a test system, so you will forgive me for that. And again, we copy. Let's leave a blank line. And then I don't know why my the copy paste does not work as expected. Okay. Okay, and then this is auth login, successful, and you see we have an access token back and an expiration value, which means essentially 1 hour. So this access token should be saved for the following calls. And what I'm showing here is essentially the calling the revoke method. In this case, I'm using the access token both as the bearer to authorize the call to auth revoke, but also as the token that I want to revoke. So in this case, I'm using the simplified call in which I let the server guess which type of token we wanted to authorize, but this method also allows you to specify if you are revoking an access token or a refresh token. So in this case, I'm copying again this, pasting here. Okay, and as well, we get 200, no content in the response because essentially there's nothing to say. If you don't get an error, then the revocation has been successful. So now let's see how OAuth works, right? So we created an access token and we just revoked it. So we cannot reuse this access token anymore. But let's use OAuth. So in this case, I have created, pre-generated the URL, which essentially has, the first part is the OAuth endpoint, and then we are using OAuth to authorize method. And here we have some query parameters. So the first one is the response type. We need an authorization code. Then we need to pass the client ID. So the client ID, client secret should be agreed between a client, for example, myself here as a developer, or Adobe Sign, or whatever other client application, and you as a service provider. So this client ID, client secret pair should be pre-agreed as part of, let's say, a partnership or commercial or developer agreement between the two parties. So again, this client ID has been generated for, let's say, a fictitious developer. Then we have a redirect URI. So for now, just for testing purposes, I'm using a localhost /login.html, which actually you will see does not exist. I'll get an error. But in real life, the OAuth call needs a redirect URI, which is the redirection endpoint that your client application should provide to the server to be called back once the authentication step is completed. Then we have a scope service, and the scope service is important because in this case we are doing a service authentication while we can also do a credential authorization with OAuth. Okay, in this case I don't need to copy and use Carl because this is a GET call. So I just need to double click on this and I'll get the OAuth login. So in this case, very simple interface. The user is Adobe Demo, password is password, and that's it. Login, the response is, as I said, localhost does not exist, but I get this authorization code, which is useful for the next step. So the next step is to call OAuth token using the client ID, and now I need also the client secret. The grant type is authorization code because we are using those flow, and the code here is what I got back here from this call. And the redirect URI should be the same that we were using here, and this is the endpoint. So copying here, pasting here again, and that's it. So now I got the access token. The access token is a token of type bearer, again expiring in 1 hour, and I can copy this and I will paste it in all the instances of the bearer that I need to use for the following calls. Okay, so now I can call the credential list, in which essentially I will ask the server to return the list of credentials that are associated with my my user. Okay, so in this case I'm also passing a max result 10, which means that if I have more than 10 credentials available, it will only return 10 and then a pagination token for the other one. Don't worry, because I only have 2 credentials here, so this is absolutely unnecessary. But just, I mean, to explain that we also have this option. Again, copying here, and I get the list of credentials. So here, as I said, 2 credentials. From the name, you can guess that the first one works with OAuth, and the second one works with Explicit, right? So in this case, I will show Explicit for the sake of time. So I have already created this info call, in which, as you can see, the credential ID is Adobe Demo 002 Explicit. So in this case, I'm also asking cert info. I'm setting cert info as true and auth info as true. So these two parameters can change the amount of information that will be returned by credential info. Credential info, again, is the method that will return some information about the credential, like the certificate, the keys supported, the authorization method supported, and so on. So again, let's copy this and paste in curl. Okay, and as you can see here, I get a bunch of data because I've asked to return a few things. So here, I will not go into all the details, but you see that the key is enabled. It supports a single signature algorithm. This is the OID for RSA with SHA-256. The length of the key is 2K, and here we have the certificates in base 64, so they can be decoded. Let's go to the bottom. Here I asked for some explicit information from the certificate, so you can see the issuer, subject, and things like that. So let's, here you have the validity. For example, in this case, it's very easy to get information about the validity. So auth mode, in this case, you see it's explicit. And then here we have information about the PIN and OTP, which of course can be used to model the user interface of the client. So for example, you may have a label for PIN or OTP, or a description. For example, from here, you will see the secret that it's not a real OTP, so it's just a dummy server. And again, here, the scale value, which means essentially, well, this credential will expect the hash to be passed as part of the request, and so on. So after the info, we can call the authorize. I'm skipping the send OTP because in this case, the OTP, as I said, is dummy. So we don't really need to call this. Actually, if I call it anyways, well, nothing happens. So you can try, but actually the OTP is a static value in this case. So let's call the credential authorize. Credential authorize is needed to get the SED. The SED is the authorization for sign hash. Okay, again, let's look at the content. We need to pass the credential ID, which is always the same. We're asking for one signature. We pass the hash because it's a SCAL2 credential. So here is the hash. That's also the hash that I will pass later in the sign hash. The PIN, 1, 2, 3, 4, 5, 6, 7, 8, very secure. And again, the OTP, super secure, 1, 2, 3, 5, 6. Again, we need the bearer to authorize the API and the endpoint. Let's copy again this and paste in the prompt. And we get the response, which is the SED that we need for the next call. So let's copy it. And an expiration time. In this case, only 5 minutes, right? So you have 5 minutes to complete the signature, but it's enough even for us going manual. So now we have the last step, calling sign hash. So sign hash takes the hash as an input, takes some parameters about the algorithm that you want to use for signing, and also takes the SED, which is the authorization for the signature operation. The rest are expected, so credential ID. So of course you can't sign with a hash for a different credential ID. You have to match the one that was authorized. And the rest is just, again, copy paste. Copy here, and again, we paste here, and the result is the set is expired. Okay. So probably was not really 5 minutes, or I spoke too long. So let me take it again. So credential authorize. So let's take the SAD here. Put it here. Ah, okay, sorry, I didn't copy the SAD here while I was talking. That's why I was using the previous one that, of course, had already expired. So copying here, and now it's okay. So we get an array. In this case, it only contains one piece of information, but this is the base 64 of the row signature made with RSA SHA-256 and the hash that we passed, and the key that was associated with my credential ID. So that's it. Of course, this is API. Well, a user based application will do something much better, but for you as technical people or developers, this is just a way to show you how the API works. And again, I hope this was useful. If you have any question, I think we have still 5 minutes for questions, or just let us know in the next few days. So I hand over to Andrea Rock again. Thank you.
Thank you, Andrea. So it was nice to see how really the workflow with one method after the other in real life. So you've seen really the different methods used or provided by the current 1.0 version. So as Andrea already told you, we are planning to work on the specification, so there will be an update. There will be a 2.0 at some times. What was for us important to really get one stable specification out, also because there are others, for example, an ETSI standard that references the CSC specification. So it was important to have an official version available that can be referenced by a standard. And then it's ongoing work to provide new functionalities in the version, but this kind of was the presentation of the 1.0. So if there are any questions, go ahead. If you want to participate in the technical working group, so there was a question, which topics you would like to work on during the next year. So thank you for everyone that answered that. So we will shortly have a kind of discussion based on that, which are really the next direct goals to work on. But yeah, that is for the moment, it's the 1.0 version that was done. And yeah, that's so. Any questions?
Doesn't look so.
No.
So very silent audience today, but I hope that everyone is already trying and testing.
Okay, no questions. So then thank you everybody for listening.
We can wrap up. Thank you again from me. And well, anything you need. I think also we will also share some information about the mailing list from the technical group. So far, we have used direct email for this, but we'll soon share our mailing list way so we can track this. So I think that also we had Matteo also volunteering for setting up a Slack channel. So I don't know, Matteo, if this is something that you will be going to help us with soon.
Yes, this is Matthew, and yes, we can start to set this up quite quickly, actually.
Okay, yeah, maybe it would make sense, because I'm assuming that now, after this presentation and also the technical work being kicked off, it would be important to have maybe something quick, and also something that will let people that are not online to follow up very shortly. So please, maybe just let's talk offline about these, and we'll let everyone know also about the mailing list for more, let's say, stable sharing of information or content. So for now, thank you, Andrea, also for preparing and hosting this. I think it was very good content, and thanks everyone for also for people who came from the US very early or from India very late. So thank you again. We'll try to always balance different time zones to let everyone participate.
So thank you, everybody. And yeah, if you have any questions, don't hesitate to send an email for any further information.
Okay.